Welcome to all of you. I hope all of you are doing well. I hope all of you are staying at home and be safe. In the last class, we discussed about the topic statistics. I hope everyone is preparing their notes and completing their work. Now in this week class, we are going to discuss a topic that is related to the geometry, which is very familiar to all of you. The topic name is circles. It is chapter 10 of your NCERT book. So we are going to start. I hope all of you are prepared for it. So please see this video very carefully. In this video, I am going to tell you about circles and its related properties. The most important thing we are going to discuss in this video is related to the topic tangent. A new topic for all of you. You have to understand what is a tangent mean and what are its properties which help us to solve a problem or to prove a problem related to circles. So I hope all of you are ready. So we are starting. Please say this. What is a circle? The first question comes in our mind. What is a circle? So a circle is the collection of all those points in a plane which are at a constant distance from a fixed point. Suppose we have a fixed point. All the collection of those points which are at a constant distance from this point, that is called a circle. So circle is a closed curve having a center, that is that fixed point from where all the distances are equal. So in the circle we have to study about the meaning of circle, the meaning of center, then the radius, the chord, the diameter, the tangent, the secant. We are dealing with all these one by one. So please see. First of all, circle. So circle is a collection of all such points in a plane surface whose distance from a fixed point is equal, or we can say is constant, always constant. So suppose we have all these points and this is a fixed point. The distance from this fixed point to all the direction is always a constant. So collection of all those points forming a closed curve is called a circle. Now this fixed point on the plane is called the center of the circle. Now the distance that we are talking about, that particular distance from the fixed point to all the points collection is called radius. So the distance from the radius to any point on the circle, distance from the center to any point on the circle is called the radius. Next, chord. You all know about a chord. A line segment joining any two points on a circle is called a chord. Like this, joining any two points. It is not a line, it is a line segment, so it should lie within the circle only, on the circumference. Next is diameter, the longest chord which is formed by joining any two points on the circle and must pass through the center. So diameter is the longest chord. Every diameter is a chord, but every chord is not a diameter. In the next part, I am going to tell you about the most important topic related to circle which we are going to study in class 10, tangent and its properties. The topic that I am going to start is tangent. Please see this topic very carefully. Now what is a tangent? A line that touches the circle at only one particular point is called a tangent. Like in this diagram, we have a circle and this is a line. This line is touching the circle at only one particular point, which is P. We have a line here, L, which touches the circle at only one particular point, P. That line is called tangent. So the definition comes out like this. A line that touches the circle at only one point. The most important condition is it must touch at only one particular point. That point is called point of contact. The point where tangent touches the circle is called the point of contact. Now, when we join this point of contact with the center, join OP, center and point of contact. And if we measure this angle, we will know that OP perpendicular to L. So the first property that comes in our mind through this tangent is the radius must be perpendicular at the point of contact. Radius must be perpendicular at point of contact. Now, we know from this whole data is any line that touches the circle at only one particular point is called tangent. That particular point is called point of contact, and the radius joining the point of contact must be perpendicular to the tangent. We will do a theorem related to this to prove this, that the line joining the center to the point of contact, which is the radius, must be perpendicular always. And then we will discuss one more property related to this, that is, if we have a circle and if we have an external point and if we draw two tangents from this, the length of these tangents are always equal. We have to prove this also, that PQ equal to PR. So we have to discuss that length of the tangents drawn from a particular external point are also equal in length. So the two properties that comes from the tangent topic is the radius must be perpendicular at the point of contact and the length of the tangents drawn from external point must be equal. So in the next part of the video I am going to show you this with the help of theorems. But before that we have to understand what a secant is. Now we will understand what is the meaning of secant. Secant is very similar to chord, but the most important difference between both is chord is a line segment and secant is a line. See this diagram? A line that intersects the circle at 2 points is called a secant, and this is the chord. A line segment joining any 2 points on the circle is called a chord. So the most important difference between secant and chord is that secant is a line and chord is a line segment. So for the definition of secant we will write a line that intersects the circle at 2 points, or we can say that a line passing through the circle and intersecting it at 2 particular points is called a secant. So the difference between secant and chord is that secant is a line and chord is a line segment. So I hope you understand all the related properties of circle. I am recalling it once again. The properties are: first, the collection of all such points in a plane whose distance is always constant from a fixed point is called a circle. That particular fixed point is called the center. The distance, the constant distance is called the radius. The line that forms after joining any 2 points on the circle is called chord, and the line that is a chord but it must passes through the center, that is the longest chord, is called the diameter. Then a line that touches circle at only one particular point is called tangent, and a line that passes through circle and intersecting it at 2 points is called secant. And the property related to tangents are: angle formed by the radius at the point of contact is 90 degree, and the length of tangents drawn from external point on the circle is always equal. Now we will do two theorems to help you all understand what is the property, what are the two properties that related to the tangents. So now we are going to prove the theorem. The first theorem states that angle formed by the radius at the point of contact is always 90 degree. The question says like that: prove that the tangent drawn at any point of a circle is perpendicular to the radius through point of contact. That is, the relation, the angle between the radius and the tangent at the point of contact is 90 degree. For this we are doing the construction. This is the circle, this is the tangent, this is the center joining the point of contact P. This is A and this is B. Now we have given that a circle with center O and radius R. AB is a tangent having point of contact P. To prove OP perpendicular to AB, that is angle OPA equal to angle OPB equal to 90 degree. Now we have given that there is a circle with center O and radius R. Also we have a tangent AB in which the point of contact is P. We have to prove that this tangent must be perpendicular to the radius, or we can say radius must be perpendicular to the tangent, as both are mutually perpendicular to each other. Now for this proof we need to do construction. What I am going to take here, join OB and take a point M on the circumference. The boundary of the circle is called the circumference. So what I am doing here, just joining this and take this point as M. Now the proof part is very simple here. We know that OM is less than OB, as OB is the whole part and OM is the part of OB. Whole is always greater than its part. Since OB is the complete length and OM is a part of it, OM must be less than OB. Now OM is equal to OP equal radii. So this is the first condition, this is the second condition. Using 2 in 1, we replace OM with OP, so OP is less than OB. That is, if we see the diagram, if I stand here and take some points in front of me and then join all these points, I will see that the straight line joining the straight point is always the shortest, and the shortest is always the perpendicular. That is, from all the points taken on AB joining to O, OP is the shortest length. So OP is the shortest of all the length taken from O to AB. So OP perpendicular to AB, as shortest distance must be perpendicular. Shortest distance must always be perpendicular. This you can prove it yourself also by taking some points in front of you and measuring with the help of thread. You will see the shortest distance is always straight line falling on that particular collection of points, and then it forms 90 degree. So we get that at last OP perpendicular to AB, hence proved. So in this theorem what I have done, we have a circle with center O and radius R. There is a tangent AB having the point of contact P. Now we need to prove that this radius is perpendicular to this tangent. So for that I have joined OB and taking a point M on OB on the circumference. Now OM is always less than OB because OB is a bigger part and OM is a smaller part. Now this OM is equal to OP because of the equal radius. So replacing OM with the help of OP, I get OP less than OB. So if I draw many lines from point O on AB, I will get that OP is always the shortest distance. So the concept used to prove this theorem is the shortest distance is always perpendicular on a particular line. So hence OP is perpendicular to AB. So now we get a property that angle at the point of contact formed by the radius is always 90 degree. So using this property I am going to prove the next theorem. So please remember this property, that angle at the point of contact formed by radius is equal to 90 degrees. So this property we are using to prove our next theorem, which is based on this property. The theorem states that length of the tangents drawn from external point are equal. I hope you understand this theorem, and I am now moving on to the next theorem. Please see that also carefully. Now I am going to tell you the next theorem with the help of the previous theorem. This theorem states that if we have an external point and we draw two tangents from it, length of both tangents must be equal. Now the point here we need to understand is that from a particular external point, how many tangents we can make? Only two. Like this. This is the external point. We can draw only two particular tangent from one particular point. So we have to prove that length of the tangents from that particular external point is always equal in length. For this we need to use the property that angle formed by the radius at the point of contact is 90 degree. So please see the question. Prove that length of tangents drawn from the external point are equal. So the diagram states like this. This is a circle and this is the external point. We are drawing two tangents here. So this is P, this is Q, and this is R. This is center. Now we have given a circle with center O and radius R. PQ and PR are two external tangents. PQ and PR are two tangents drawn from P. To prove PQ equal to PR, for that we need a construction here. We will join OP OR, OQ. Now we know that angle at the point of contact is 90 degree. So now we have two triangles and we can prove this using the concept of congruency. So the concept here is that we have a circle with center O and two tangents from external point P, that is PQ and PR. We know that angle at the point of contact formed by the radius is 90 degrees. So we have joined OQ, OR and then OP. Now to prove, we can take two triangles here. The name of the triangle is in triangle POQ and triangle POR. So the first thing is PO equal to PO, common. Then OQ equal to OR, equal radii. And also angle OQP is equal to angle ORP, each 90 degree. So here we have the opposite side of 90 degree equal, that is this. So the criteria here is RHS, right hypotenuse side. So the triangle is POQ congruent to POR by RHS criteria, because in this we have a right angle, hypotenuse and an included side. As we have radius, then we have 90 degree and then we have the hypotenuse. So the criteria used for congruency is RHS. So by this we get PQ equal to PR by CP, CT. Hence length of tangents are equal. So using the first theorem concept that the angle formed by the radius at the point of contact is 90 degree, we know that if we draw two tangents from an external point, the length of those tangents must be equal. So I hope all of you understand both the theorems. I am recalling it once again. The first theorem states that angle at the point of contact is 90 degree by the radius, and the next is length of the tangents drawn from any external point is always equal. So try to understand both theorems and try to do more practice related to the theorem. Try to write it 4 or 5 times so that you understand it well, and try to read all the properties related to circle. In the next part of the video, we will do some questions related to circle. Thank you.